When it comes to innovative single-family construction, Con Frank is at the top of the industry. These all-electric homes, both net zero energy and net zero emission, are truly built from the perspective of demonstrating independence from fossil fuels. Passive solar design, insulated concrete forms for construction, Energy Star windows, ground source heat pumps for heating and cooling, and so many other cool features show just what is possible in the future of home building. We're lucky enough to get a tour from the owner of this impressive home. So let's go take a look. I need one of these. We're talking to homeowner Wes Geary and builder and designer Con Frank about what makes this home so cutting edge. And what do a set of keys have to do with testing the envelope in a home? Find out a little later in this program. Con, definitely want to pick your brain on many things today. This amazing house that you designed, built, it was your vision to put this here with such great features, passive solar features, great insulation, great air sealing. Why did you choose to design and build a home with these features? What was the driving force for you?
Well, I've been in the business since 1978. Built a lot of different things for a lot of different people, and we've explored a lot of different types of equipment, types of processes. This is an accumulation of all of those things kind of put together.
As I've known you, Con, you really, the title or term I put to you is you're an inventor, somebody who invents things in buildings by experimenting and doing things with them. Tell me a little bit about, going back to when you were a young lad, what did you do? Who were you? Were you the bane of your parents' existence, taking apart the toaster and doing stuff like that? Or what did you do to learn this stuff?
I've always been pretty curious, and I grew up on a farm. It was a pretty big farm, and so when my folks would go to town, we would find things to play with. And so we took
right?
Took things apart. Sometimes they got all back together again, sometimes it didn't. Started building 1978 is when I got my first contractor's license and went on my own. And we did a lot of energy efficiency stuff. We did a lot of solar.
Why'd you do a lot of energy efficiency stuff in 1978?
We had gas shortages,
okay,
gas lines,
okay,
all kinds of stuff like that in the early 80s. I grew up in Dickinson, North Dakota, where we had an oil boom going on, and people came in, and it gets cold there. And so some of the people came in were engineers for the oil companies, and they wanted better than normal housing. And so we built earth berms homes, we built super insulated homes, we built all kinds of stuff, and that was before we knew about the indoor air quality, and polluted the hell out of those poor people, and had to go back and correct things and do whatever as we learned.
I've always been interested in modern homes, modern technology, modern new things. And so when my Aunt Maxine was here visiting from Texas, we went and looked at some really expensive homes because just for fun. And some of the homes down on around First in Quebec were being built with the geothermal and things like that. And the people were happy to tell you all about the features of the home. And they were $1.4, $1.5 million homes. You know? Said, well, that's really nice, Get out of here quick, But I got interested in this home again because it was in the neighborhood. It was so different. And watching it being built, I was just always curious about it,
Yeah. So how did you and Con finally connect? Did he bump into you? You call him?
When the home went up for sale, when it finally finished, I got the nerve to come up and come in and look at the house, And they had an open house one day, and Con was here. I'd never met him before. He told me so much it was over my head, but I could tell he was really passionate about, number one, the environment, but number two, people's health. He was really concerned about people's being able to breathe well in a home, be comfortable, but also live economically. He was just passionate about all the good things you could do with a house.
So Con, in the case of this home, if you don't mind sharing, it can be ballparkish, but a typical home is about $450,000 in this size. Where did this home come in for you? Or maybe the other homes, maybe not Wes's home, maybe the other home across the street that you built exactly the same way. How much did that sell for, if you can share?
I think this one was 5 1/4, right, Wes? Yep.
Okay.
The one across the street was just under 5, but we didn't finish the basement.
What you did in this home, we're taking some old principles that have been around for a long time. Mesa Verde down in southwest part of Colorado to use passive solar was there, but you also used a lot of advanced technology to what you're doing. So when you started building the home for the envelope, so the thermal envelope for it, tell me some of your choices and why you chose them.
We evaluated the conventional construction, which everyone has done for many, many years. We evaluated some of the SIPS panel stuff. We did the ICF.
So an ICF, insulated concrete form, it's going to have, in your case, it's got 4 inches of foam,
2 5/8 on each side.
2 5/8, okay, on each side, and then concrete in the middle,
Yes.
poured in on site. Yeah.
Right.
So,
And so we're insulated concrete forms all the way to the trusses. We have high-heeled trusses. And so we sealed all the trusses from the concrete up to the baffles, up to the airspace for ventilation in the attic
Right.
with foam. So that is all sealed because that's the biggest culprit in air infiltration in the house. Heat transfer and air infiltration. And so we kind of covered all these little details. I've been working with energy raters like yourself and people through the many years, and with their cute little infrared cameras, and when we do the studies and we do the air blower tests, you can see many different things over the years.
right.
And so we've pretty much put all that together in one package.
Hey, Paul, come on in.
Hey, Wes,
How you
thank you
doing?
so much. Good to see you again. I've come back following the interview to do a quick blower door test, which is always done with energy audits and more commonly done for energy code compliance these days to quantify the air tightness. And today I'll do it for Wes's home. So if this home had been built to code, it'd be like 2,500 instead of down in that range. Tell us about what you did with the windows and how you decided to orient the windows and orient the house, really, for the passive solar benefit.
We set up the houses in the whole subdivision to best access our southern access. We use triple pane windows with argon filled gas. We use special window bucks compared to what most ICF builders even use. We personally build those and we insulate them because a lot of them will put the wood window bucks in, and in 25, 30 years from now, all that condensation has collected in there. You slam the door, the window falls out.
Exactly.
It leads to a lot of thermal bridging. It leads to a lot of air infiltration around there, which we've eliminated.
You happen to know the U value of the windows that you installed?
The fixed glass in here were 0.20.
Okay.
The operating glasses were like 0.21 and 2.3.
Extremely good. And then, as I understand it, you did some different solar heat gain coefficients with the glass on the south side versus other sides of the home. Is that correct?
We very specifically picked glass that will allow solar gain for us in the wintertime.
Nice.
And so we can have quite a bit of solar gain, BTUs of solar gain in the wintertime, and in the summertime, the R value or the glass reflects it off, and we don't get much gain out of it.
I'm going to guess, you tell me if I'm in the ballpark, I'm going to bet the windows on the south side are letting in 55 to 60% of the sun.
56.
56, good. I'm in the ballpark. That's good. Good. And then on the other sides of the house, probably only 25, maybe 30%?
I think we're at 31 or 32.
Okay.
I like the way that they designed this side of the home to be cool in the afternoon. So my patio is such that about 4 o'clock, 5 o'clock, there's a shadow there.
Right.
Where the way they shaded the home. And I said, that's so smart. I used to have a retractable awning at my other house. I don't need that here.
My fascination in having known you and worked with you over the years is what you've done in alternative ways once you've built a great envelope to heat and cool it. And you've done some really good things here that aren't done commonly. You have a ground source heat pump system, so I'd love to hear about that. And then I'm going to ask you about how you went about sizing it, because that's part of the beauty of what you do with your projects.
Ground source heat pump is the most efficient system that the EPA determined that many years ago. That ground source heat pump is the most efficient way to heat and cool any building that there is.
Tell me a bit on this one. How did you choose to install the system as far as the bore field went and some of those details?
In order to size any kind of bore field for any system, you really need to do a good heat loss calculation. I've worked with many mechanical engineers already over my lifetime, and they will do the heat loss calculations and they'll be double of what they really actually are.
As far as the size of the equipment.
As far as the size of the equipment.
Yep.
And so by putting in oversized equipment, you take away efficiency. It's like taking your little car and putting the biggest motor you can stuff under the hood and punching it at every stop sign.
Right.
That's the same effect.
What's the size of this system approximately as far as the tons?
2 ton.
2-ton cooling. For a home, how big? 28?
There's 1,970 square feet per floor.
So a 2-ton system. I've done enough load calculations, I bet the software I would use say at least, even with your good envelope, at least a 4-ton is what I bet I would have gotten from the calculations.
That's
Mine
what,
is
right.
about
That's
right.
what the software comes up with.
Yeah. Then for safety, you needed the ERV. So tell me about some of the cool design features you have built into this house, how you have air moving through this home, especially underneath the basement floor deck and some things like that. But
We have a unique situation here where we had some expansive soils. And so we have a foundation that is lifted actually 6 feet off the dirt. And it sets
wood
on
floor,
stilts.
right? Yeah.
No, it's concrete.
Oh, concrete. Okay.
It's concrete,
Okay.
and it's lifted 6 inches off the dirt.
Okay.
And so we got a void space under there. In that void space, I have airflow that is connected to the HRV. And so we have constant temperature air from the mechanical room, which is where warm stuff is, water heater, furnace, things like that. So we pull that warm air from that mechanical room where we really don't need it, and we pull it underneath the slab, and we pull that stale air underneath the slab with all the radon and all that wonderful ugliness that happens down there,
Soil gas,
and we dissipate it outside.
So the ERV itself that you chose, who was the manufacturer? Why'd you choose it? Then how do you have it ducted in and around this home?
It's actually a Brown HRV.
It's an HRV. Yeah, it's a
And
heat
we
recovery
have,
ventilator.
we choose the HRVs because once you seal up something this tight and mama starts cooking for Christmas and making a hell of a bunch of steam in the house or whatever, you need to dissipate that moisture.
Right.
And so that's why we chose the HRV. And so we have sensors in each one of the bathrooms, the laundry room, and the kitchen. That's where you make your pollution mostly. Doing laundry, doing cooking, going to the bathroom, taking showers, whatever.
Right.
And so the HRV runs at a continuous flow of like 68 cubic feet per minute flow to keep the air fresh in the house. Once you step into a bathroom or the kitchen or laundry room, it'll ramp up to 200.
So Wes, as an accountant, I love this about you. You've been tracking the data on your utility bills and tracking how your solar PV system has been performing.
My other home was about half the size of this one, maybe a little over half. But that house had about a $100 a month average utility bill. And this house in 2019 had a utility bill of about $260
For the whole year.
for the whole year.
That's fantastic.
And I get cooling in the summer, whereas the other house was hot in the summer.
Tell me a little bit about this, electric air source heat pump water heater that you put in.
It comes from Germany. They have been using them in Europe, in Japan for 25 years.
Right.
Because their electric rates are 3 times as what ours are.
Right.
And since we were going all electric in this house, I explored quite a few different manufacturers, and I came up with this system, but they don't sell the airflow kit in this country.
Okay.
They only sell the water heater.
Okay.
And so we had to make up our own airflow kit.
And the airflow kit, just to interrupt, it's because
Was
an
a
air source
booster
water
fan.
heater. Okay, it's a booster fan?
All it was a booster fan, a very noisy, holy crap, hold on to your hat booster fan. There's a high return at the ceiling.
Right.
We're pulling the warm air off the ceiling where you never heat it.
Right.
In the summertime, you're getting radiation through the insulation even.
Right.
So you've got all this warm air stacked at the ceiling.
Right.
And so when the water heater needs heat, it starts pulling that warm air off the ceiling, runs it through the water heater, extracts 6 degrees of temperature, and deposits it into the
Water.
return of the furnace.
Oh, okay.
There's refrigerant coils that go around the tank in the water heater, and so that's how it exchanges the heat.
And, all these things are amazing, in my opinion, in this home. And you've built an all-electric home that is affordable. Tell me a little bit about why you did this. Why an
To
all-electric home?
prove that it can be done.
Okay. Because people are saying they're telling you that you
Yep.
couldn't. do it.
Everybody says that in order to do what we're doing, it's going to cost several $100,000 more.
So Wes, you've shared enough with me over time that we've known each other about how you care about many big picture things, whether it's connected to your church, things with working with underprivileged youth. Seems like that's part of your decision making in getting this home. Am I right?
You're right. I hate to admit that, but yes, you're right. That was part of the decision making with the home. I've always felt like if you could use less resources, you're going to help the environment. And I went to an energy conference at the First Universal Church, and First Universalist, I think it is, and really learned more about the impact that using energy here has in other places, in poorer countries. And so didn't realize how much of what we enjoy hurts others when we're irresponsible about it. So that also had an impact on my decision to do this, because I didn't need a house. I had a house paid for, I was retired,
So value is beyond the
Beyond
ledger
money,
sheet.
I know. I'm probably going to lose my CPA license. But yes, there are valuable things besides money. There's people's lives and their well-being.
I'm deeply impressed by the passion of this builder and this buyer to have high levels of sustainability in this home that is attainable for middle-income people in our country. Remember seeing me drop my set of keys at the beginning of the story? When performing a blower door test, the HVAC system and the domestic hot water system has to be turned off. I leave my keys on the floor so I remember to go back and turn the systems back on. I don't want to leave a homeowner sweating or freezing or without hot water after I leave. Well, we've tested Wes's home, and now, so I don't leave him in a home that's going to eventually start warming up, we're going to turn the cooling back on for the house. There we go. So, the house actually cooled down by a degree while we were operating the blower door, which is pretty fascinating. Wow. Thanks to Wes for allowing us in his home and sharing some of the wonderful design features, and to Con for taking us through his thought process. Thanks to both for sharing their why behind sustainable living